Dear students, in this presentation, I will be discussing another topic from Module 1, that is structures and unions. Before discussing detailed information on structure, we will see one example why structure is required. Now, I want to maintain details of some 10 books. Details pertaining to textbooks are book ID, which is of type integer, book title, which is a character array, and a price, which is of type float. These three information I have to maintain for all those 10 books. If I want to write a program in C, at least I need 30 variables. 3 because book ID, title, price 3 for 10 books. 10 into 3, total 30 variables required. This is a scenario when I want to maintain information about 10 books. And the number of textbook grows, the number of variables also increases, which leads to problem. The difficulty to use such huge number of variables in the program, very difficult to handle. So this method, use of individual variables for all these, is ruled out. The second option, I can use arrays. Three different arrays required. Why arrays required? Because I'm having 10 books in this scenario, in this example. One integer array for book ID, another string array for book title, a floating point number array for price. Totally 3 arrays required. Size of these 3 arrays 10. In this example, size of ID, book title and price is limited to 10. If the number of books increases, size also be increased. I can use those three array variables in my program, but suppose a wrong index is used. You know that to refer, I'll be writing it here, to refer first book like book ID, I have to use the index 0. For title, I have to use the index 0 for the first book. For the price also, I have to use the title 0. Right. So these three are the array name, and this is the first index that refers to the first book. Using these, I can read the data or I can retrieve the data. By mistake, if array index is changed, so this will refer other book which is of which is not required. A wrong usage of index that will lead to a problem. So array is dangerous. You have to handle all these variables, all these index properly. That is the problem in case of array. Next, third option is I have to find out some other method. Our C language supports us to combine these fields. I will be calling these as members. I will be calling ID, title, price as members or field. Okay. For one such book that is called a record, that record has got 3 fields. So C supports us to define our own new data type. That new data type is called structure. Okay, where the member can be of different data types. That is the topic of interest in this presentation. In C, a structure is a user-defined data type which creates a data type that can be used to group items of possibly different data types into a single type. That single type is known as user-defined data type or a structure. We are going to form our own new data type for our problem to solve our scenario. The syntax is like this. Keyword struct you have to use lowercase struct, lowercase struct, and the structure name. Any number of members we can have, but all the members should start with the data type of the member name ends with a semicolon. So these members should be enclosed within curly bracket. At the end it is semicolon. It is similar to the way in which you declare a variable. Like suppose I want to declare a variable of type integer. This is the way that you follow. Semicolon. This int is this variable name. Int is the data type. This is the our new data type that we are going to create. Struct name, it is similar to int. Then variable, we will see that later. That is our variable name. So here you should note that keyword struct is used. That will create a user defined data type. Another way is that I can also alias that structure name in my program. Sometime what we use now, when we create structure, we may use a long name which may not be so easy to use that in the program. For that, aliasing name is much useful. To create that aliased name, other name, alternate name, I have to use the keyword typedef. Typedef, struct, structure name, members, but here you note that this is an alternate name. This alternate name is used for this structure name, alias name for this structure. So typedef keyword is used to alias or the declaration or the definition of a variable. Here we use it for aliasing a structure. You can also use that typedef for defining a variable or for declaring a variable. That is also possible. We'll see one example here. In this case, actually my data type is character, but I want to alias this one. I want to have alternate name for this variable character in my program. Here afterwards, I'm using instead of character new data. This is my new data. New data for what? New data for character. I will not be referring character anywhere in my program. Instead of character, I will be referring it as new data. So I'm going to create a variable. If this is not there, the actual line is charb. But I have redefined, I made an alternate for character, that is new data. That is my alias name. Alias name, alternate name, that is new data, and a variable name. Okay. So here I want to input the data. Percentage C. Percentage C. You're going to input a character B. B is of type character. Why it is character C here? Because here you defined. B is of type new data, that is alias name for character. Okay, you are going to input a character. We'll take a character as A. That is my input. Next, you're going to print it as usual, that is thing. But here you note that typedef can be used to create an alternate name to alias a name. In our program, in structure, we use typedef keyword to make an alternate to alias a structure variable. Okay, it is shown in the example. Now we'll see different ways to create structure. Here A distance structure is created which is having two fields. I took two fields, one is of type int, other is of type float. Feet and inch are two members of the structure. Feet is of type int, inch is of type float. In my program, I'm going to create two variables. These two variables are d1 and d2. d1 and d2 are the variables of type distance. What is the distance? It is a structure. Struct distance d1, d2. This is one way of creating a member. What is the other way? You see, this is the second way. Here, I used an alternate name. I don't want to use this variable, this name in my program, but I wanted to have alternate. To have that alternate, use type def. That's all. You just start with type def, struct distance. Here, this distance, lowercase distance, is created for the structure distance, which is that structure is having two members. One is feet of type integer, other is of type float, that is inch. The rest of the things are same. So I'm going to create variable d1 and d2 which is of type distance. What is the distance? Distance is a type structure distance. This is the second way of creating the structure. You can use any one of the method. Okay. Third way is like this. Structure is defined as usual, just like the syntax one. Now I'm going to create a alias name type def struct distances. These are the alias name for distance. I can use d1 or d2. In my program I can use d1 that refers distance. I can use d2 that also refers distance. In that way, so any syntax you can use it, the first one, second one, or the third one, anything is okay. So if you are familiar with those who studied this subject in your previous course, this particular topic in your previous course, hope you are comfortable with this syntax. You can follow it. Any one of these three syntax useful for writing the program. Now, whenever you use a variable, we may have to initialize, but structure will not allow us to initialize variable inside the structure. This is wrong. Both are wrong. You can't initialize variable here. I can't put value. I can't initialize 4 to feet, or I can't initialize 4.2 to inch. This is the wrong way. What is the right way? This is this is a proper method of initializing a variable. This we have seen earlier. Distance is my variable. Sorry, d1 is a variable of type distance. Now two members are initialized. This 4 will go to the first member always. The first is to the first member, second is to the second member. If there are more than one member, you have to put a comma. 4 always for the first member, this one for the first member, second data for the second member. If you don't have any other data or capacities, that is uninitialized one. Third way of is more specific one. This gives the more clarity. A structure is defined. Structure is having two members. Members are inch and feet. Inch is of type int. Feet is of type float. I just change the variable name. That's all. Okay. Feet and inch are the two variables. The structure name is distance. Alias or alternate name is distances. I created a variable d1 which is of type distance. Distance, this one. Now I can interchange these two places. This is the way I can interchange it. No problem. You can give these things anywhere. Here, the second member is started first. Okay, you can also start the first member. Dot. Note that the dot is required. Dot feet value, comma, dot inch the value. You can give inch here or in that place. Anything is okay. But you are giving the clarity to which field you are initializing the data. This is more preferable, custom initialization. This has got more clarity. What value you are assigning to which member. Okay. So these are the three different ways, and these are the two different ways to initialize. Now, how to access structure member? A structure is defined, again, same example. Distance is a structure. Distances is alias name. Distance structure has got two members, feet and inch. Feet is of type int, inch is of type float. A variable is declared. D1 is a variable. Members are initialized. 4 to feet, 4.3 to inch. Based on this example, 4 to the first member feet, 4.3 to the second member, that is inch. Now how to access it? I want to alter the first value, that is feet value. I have to alter it. For that you have to use dot operator. Dot operator is used to access a member. What is the variable name? Here variable name is D1. Which member you want to alter? Feet member I want to alter. Feet member, say which member I want to alter. The feet member I want to alter. The old value, it was 4, now modified to 5. To access a member, remember that you have to use dot operator. Dot operator. Here old value is altered by the new value. Old value was 4, it is modified by new value. In the same way, I can read a value as these two are of primitive, that is integer and float. Use proper format specifier. The first member feet, second member inch. D1 is a variable. D1 feet member. D1 inch member. So use resolve it using dot operator. You are going to read. For that ampersand is required. In case of numeric, float, double and long character, ampersand is required. For string, that is not required. Ampersand is used. It is similar to accessing a variable. Here you have to remember that you have to give dot operator. Structure name, structure variable name, dot member name. That is important. The same way we are going to print it. To print it, again, structure member name, structure variable, and dot operator. Okay. Accordingly, you can access it. Any member can be accessed with the dot operator. Now, we'll go back to that example which I told earlier. Now, same 10 textbooks information I want to maintain. So, I can use structure. But problem is, if I use structure variable, I need at least 10 structure variable. 10 structure variable for the 10 books. Again, it is difficult. If the number of book grows, I need to use that many number of variables. If there are 1000 books to be stored, I need 1000 structure variable. It is not at all possible to program. The last option is to use array of structure. Array of structure. The index is important. Here I will be creating, as I told earlier, I can create an array. I can create a structure. Structure name is book. Having three members. One is ID field. Second one is title field. And third field is price field. These are the three fields. I can access these with the dot operator. Like if B is the variable name for the book, B dot ID, B dot title, B dot price. This is for individual variable. Suppose to maintain 10 books, I need to create arrays of structure. This is the way. Array of structure. Array is created which is of type book. Book array is created like this. This is not just a ordinary variable, it is a book variable. Now to access third book, index value is 2, structure variable name B, third book index 2, ID field is ID. comma b of 2 dot price, comma b of 2 dot title. This is a way. Remember to use this index value. If there are n numbers, that many number of index I have to use. Again, there is a problem, but it's okay. I grouped everything with one name, that is B. Variable name used is only one, that is B. These are all the index, these are all the members. In that way, I can modify my program. Same is shown with an example here. Again, distance structure is created. Alternate name for the structure is distance. Two members are feet and inch. Feet is of type int. Inch is of type float. Structure variable is created. D1 is the structure variable and which will hold 5 information. Index are 0, 1, 2, 3, 4. Which is of type distance. How to access the first book or how to set the value for the first distance, sorry, not the book, it's distance. D1 of 0 dot feet equal to 5. Remember that you are using index. In the same way, you can set the second member also for the and the distance D1 of 0 dot inch equal to 5 something. In the same way, you can read it. D1 of 0 dot feet. D1 of 0 dot inch. Ampersand because these two are primitive values. In the same way, I can display it. D1 of 0 dot feet, D1 of 0 dot inch. Now, we have seen in some program how to use pointers. Pointers will hold address of a variable. Pointer holds the address of that variable. In case of dynamic allocation, pointer is very much useful. To access a member, as you have seen earlier, dot operator is used. But when it is a pointer type structure, you have to use arrow operator. Arrow operator. We'll see that with the program. Okay, same structure, distance structure, having two members, feet and inch of type int and float. Alternate name is distance. Now, I will be initializing a variable d1 with values 4, 4.3. Now, I will be creating a pointer variable d. This d holds address of d1. D holds address of d1. D is a pointer variable which holds the address of d1. The size of d1 is size of int plus size of float. If size of int is 4 bytes, size of float is 8 bytes, then size of structure is 12 bytes. That is the size of d1. Size of this d is size of the pointer. It is a long, so the size of d is 8 bytes. Size of d is 8 bytes. Size of d1 is 12 bytes. Rest of the things are same. Just note that d arrow feet. Instead of dot, you have to use arrow. If it is a pointer, use arrow. If it is a pointer, d is a pointer, so use arrow operator. Arrow, not the dot. If it is not a pointer like d1, you can use dot. For d1, you can use dot. For d, you have to use arrow. Okay. This is a way. D is a pointer, so you have to use pointer, arrow, like that. Now, how space is allocated in the memory? How space is allocated in the memory? Suppose a structure is defined, structure name is data, having two members, C and D. When memory is required for variable, it will be given in terms of blocks. not just like 1 byte or 2 byte like that. In set of bytes it will be allocated. Usually it is a 4 bytes or 8 bytes or 16 bytes like that. I will be taking one block, one bank of size 4 bytes. Now what happens? When you are allocating space for data, the 4 byte are reserved for C like this. These 4 bytes are reserved. A set of 4 bytes allocated to C. Another set of 4 bytes given to D. Unfortunately, size of character is 1 byte. It is wasting 3 bytes. This cannot be given to any other data. This cannot be given to any other data. These 3 bytes are wasted. As you have seen earlier, size of this is if you declare the structure like this, and if you are printing the size of this structure, you will be getting 4 plus 4, total 8 bytes. Why 8 bytes? 1 plus 3 wasted here. Keep this diagram in mind. 4 plus 4, 8 byte. It is not 5 byte, it is 8 byte. Is any way to save the that wasted memory location? Yes, just by altering the declaration part, I can save that space. I can by rearranging the members, I can save some memory locations. What is that? Always you give highest size in the first place. Go on, do like that with the least size at the bottom. Instead of simply declaring the member no, you see that which member is of highest size. Declare it first. Like that, in the decreasing order of the size, you declare the member. Now we'll see what happens. When you do like this, 4 bytes are reserved for integer. Another 4 byte will not be given. Just 1 byte is given because it is character. Over. Only this much space is given to variable data. How much is that? 1, 2, 3, 4 plus 1. Total 5 bytes are reserved. Compared to the previous case, we achieved a big, right? 3 bytes saved now. Earlier, 3 bytes wasted. Now these 3 bytes are not given to this data. It is free. It is free. Can be allocated to any other variable. So here in this case, if you rearrange the variable in the decreasing order of the size, you can save the space. While when our question comes, whenever you are asked to declare a structure, always prefer in this way. Instead of simply declaring no, you always declare it in a proper way, decreasing order of size. Okay, size of empty structure which is not having any member is 0 byte. Size of empty string is 0. Size of empty character like that. Size of empty structure is 0 byte. This you remember it. In this case, size is 5 because 4 plus 1 is 5. In this case, don't decide the size by seeing the members. You have this kind of diagram in the mind, then you decide it. Just by looking to the member, just by looking to the structure, no, don't decide the size. Keep this kind of diagram in mind, then you decide the structure size. Okay. The next topic is self-referential structure. There are some cases we have to create a dynamic kind of array where the nodes are in different places. I will be drawing that here. This is one node. I want to create array. Array is having 3 members. In case of static allocation, all these 3 locations are continuous. But I'm finding shortage in memory. Spaces are there, but continuous spaces are not there. I will go for dynamic allocation. Now I will be allocating 3 nodes. I will be calling this as nodes. I will not worry for number of bytes required. Some bytes here. X number of bytes, X number of bytes, X number of bytes. These 3 nodes are allocated now. But I want to have a kind of array. You know that in array, elements follows one after the other. This element first, this element second, this element third. Now that means I have to have some information here. The information is the address of the second node. I will be taking address of these nodes as 10. Don't get confused. These are all address. Okay, not 10. It's 100. 200. These are the address of these three nodes. 100, 200 and 300. Now these three nodes are allocated dynamically, need not be continuous, dynamically allocated at the time of execution. But I want to form a list. The list says that element will be arranged in one or other way. Okay, that means the first element, second element, third element, like that. To have that kind of thing, these nodes should contain one extra information. The extra information is a pointer which is pointing to the next node. A node must contain, this is the data, this is I'm not telling, this is the data part. I'll be writing that as D, some D. These are all data. D is my data. D is data of node 1, node 2, node 3. The second node, another field should be maintained. That field will hold the address of the next node. For the first node, the next node is this one, whose address is 200. That 200 should be placed here. Okay. Next, third node is this one, whose address is 300. 300. Okay. Next, one second. Okay. Next, third node address is 300. That is kept here. That is placed here. Now that is logically written like this, arrow with arrow. This is the arrow. The pointer node should be maintained. Another field is called pointer. That is the self-referential structure. This pointer points to another structure. This pointer points to another structure. Now that is the member here. That is self-referential member. These two are the data. No, this is the pointer, which is of type same as that of structure. The type of this is same as that of the structure. Self-referential structures are those structures that have one or more pointers. In this example, one pointer is shown, which point to the same type of structure. See here. This points to the same type of structure. This is a structure. This point to the same type of structure. This is of type same type of structure as their member. Structures pointing to the same type of structures are called self-referential in nature. These are all self-referential in nature. This kind of structure is called self-referential structure. Okay. In the above example, in this example, link is a pointer. Link is a pointer to the structure. Now what I will be doing now, I will be modifying this diagram with a small information here. The first field is feet. Simply I will be writing it as F. Second field is I, and this field is that link field. Okay. The first field is feet, second field is inch, third field is link. First field is feet, second field is inch, third field is link. Same way here. That link field holds the address of the next node. The next node is also a structure. Next node is also a structure. That address is kept in the previous node. So link is a pointer to a structure of type node. Hence, the structure node is a self-referential structure with link as the referencing pointer. Now, there are two different ways. One with a single link, other one with a multiple link. We'll see that with the program. A structure is maintained, a structure is created with the two members. One is the data member, other one is a pointer to the structure. Data one is a member and link is a pointer. I will be creating two variables OB1 and OB2 of type node. Okay. Now what happened? I'm setting link field to null. I don't want any data in that link field. I'm setting 10 to the data field. After that, no, a node is created. This is the address of OP1. 10 is put here. A null. I'll be indicating that with the cross mark. So OB1 is created. This is OB1. Okay, the same way OB2 is created. OB2 whose address is 1200. This is OB2. This is OB2. OB2 data part is 30. Link part is cross null. But I want these two as a list. Now these two are individual nodes. Now I want that in the form of list, one after the other. For that, what I have to do? I have to put address of this node 1200 here. In the link field, I have to put the address. How to do that? In the link field of OB1, in the link field of OB1 here, the address of OB2 you have to put. The address of OB2 is 1200. That you have to put it here. Okay, that is indicated with an arrow. Actually, you are writing that logically like this, diagrammatically, but here 1200 is placed. Because of that line now, 1200 is copied to the link field. There is no more node after this. In the at the end, no special information is maintained, that is null. Then you try to print it. OB1, this node. Data 1 field, this one. The value is 10. 10 is printed. OB1 dot link 1200. Whose 1200 is this one? 1000 OB1 dot link means 1200. That is this one. That node data field 30 is printed. Okay. Now we'll see one example which is having two links. We'll call that as left link and right link. Data field plus two links, left link and right link. In the same way, created two nodes OB1 and OB2. Set left link and right link to null like this. Okay. Here also cross mark. Here also cross mark like this. OB1 is created. Value is set to 10. Second node is created. Whose value is 30. Both are set to null. Now I want a direction, means after the 10 I should go to this node. After this node I have to come back to this node. Means I have to set both direction, bi-directional for this. This is the representation, how to write that in the program. If I assume the address of this as 100, address of this as 200. Now what to do? After 10 I have to go to this node having element 30. That means the address 200 you have to copy it here. Where to copy? There are two links. One is left link, other one is the right link. In the right link of first OB1, that is OB1 here. This is OB1 and this is OB2. OB2. And this is left side. This is right side. This is left, this is right. Tell me how to do that one. OB1 dot which link? Right link equal to ampersand of OB2. That is a statement. OB1 dot R link equal to OB2 L link. Okay. Then OB2 dot OB2 not this one. This is not there. OB2. Address of OB2, that is 200. OB2. Okay. In the same way, what to put here? In the OB2 left link is OB1. This is the way. OB1 only. OB1 only. Okay. So by having these two lines, I can go to the next node or to the previous node. I can come back to the previous node or I can go to the next node. When I'm trying to print that, we'll get 10 and 20. OB1 data, that is 10. OB1 right link, OB1 this node, right link that is 200, whose data field is 30. Answer is 30. In the same way, OB2 data part 30. OB2 left link of data. OB2 this one, left link this one. The value that is there in that node is 100, means this node. The data field is 10. 10 is printed. Okay. Analyze this program again. Now, as we know that unique ID, we say unique ID. That is the ID used, which will indicate, which will refer, which will identify particular data item. Like in our case, we have got different types of IDs. Some IDs are provided by the institution, some IDs are provided by the government. Okay, like PAN number. No two-person is having common PAN number. No two-person is having common Aadhaar ID. That means Aadhaar ID is a unique number. PAN number is a unique information. Phone number, sometime we may share, but I can some in many organization no, in many application no, that phone number they are considering it as a mandatory information, unique information. In the same way, mail ID. But it is not necessary to give all the things. I'm having my own phone number. I'm having my own mail ID. I'm having my own PAN number. I'm having my own Aadhaar ID. It is not necessary to give all four information. Any one is enough. I may prefer to use mail ID as the unique information. Somebody may use PAN as a primary information. Somebody use Aadhaar as a primary information. Someone phone number as a primary information. I don't want to take all four information, but any one is enough. How to utilize one such of the member of many no, how to utilize one of that one, that can be done with the help of union in C programming language, which stores different information but in the same memory. How it is possible? First we'll see the theoretical aspect. Union, which will provide an efficient way of using the same memory location for multiple purposes, that the space is equivalent to the space given to the highest space. How much is result here? In case of structure, sum of size of all the members, but in case of union is the size of the member. Size of union is equal to member which has got highest size. In case of union, that is a member which has got highest size. So exactly one member stores a value, not more than one. We'll see with the example. This is syntax. Syntax is similar to structure. Keyword union is used. Instead of struct, keyword union is used. Rest of the things are same. We'll see with an example. Here, a union is defined. Data is a union with three members. L, I, S tier of 5. These are the three members. If I assume size of long is 8 byte, size of integer is 4 bytes, size of this array is 5 bytes. What is the member which of these member having highest size? The highest sized member is L. Size of this union is 8 byte. That means for 8 byte is reserved. This is the maximum memory allocation done. So in this, either I can put L or I or array. Okay, 8 bytes long. Size of this union is 8 bytes. How you are computing that size? Find out the member which has got highest size. In this structure, highest size is L. Suppose I'll be changing this declaration. Instead of 5, 15 I'll be doing. Now, size of this member is 8, size of this member is 4, size of this is 15, then 15 bytes allocated. 15 bytes allocated. That is the size of the union. Size of the union depends on size of the data member which is of highest size. In this way, it is result. We'll see with one example. Okay. You follow the same way. Here it's not a matter. You can give anywhere, but maximum allocation size So the member which is highest size. In this case, it is 4 bytes float, 8 bytes, 20 bytes. Size of this union is 20 bytes. Okay, size of this union is 20 bytes. Next, what I'm doing now, I'm okay. I'll be reserving 20 bytes. This is a 20 bytes. Why 20 bytes? The maximum size is 20. Now, out of the 20, 4 bytes are utilized, that is 10. Only one member is active. Out of 3 now, only one is active. I remaining two are ignored at this stage. Now, the member F is defined 220. This one gone. I gone. F value 220.5. Only one member is active. Now, member F is active. I not in use. F is now active. Earlier I was active, now F is active. Previously defined member, I member was defined, but that is ignored. Or we chose the garbage value. In that, if you are trying to accessing that member now, you will get garbage value. Okay, we'll see that with the program now. F, I know that floating point. I, I know that it is of type integer. We'll see what happens. Which is active member? F is active member. What is the value? 220. 220 is defined. 220 is displayed. What about the other one? It will be set to garbage value. It will set to garbage value. This is the thing. Okay. Now a small example. Just go through this in your free time. A structure is defined with the two members 10 and book ID, the title and book ID. Title size is 10, book ID size is 4. Size of the structure is 10 plus 4, 14 bytes. Here a pointer is defined, a variable is defined. B1 is of type book pointer. B1 is a pointer variable which will hold address of another book structure. B is a book structure, two members are initialized. C book is title, 112 is ID. Okay. So what happens now? Memory allocation happen. Memory allocation happen. Okay, this is for B. This is for B. The address of B is 6487552. The first member is C book, second member is 112. Next, memory allocation happened. I told earlier that CLOK is the best way because all the things are nullified. I need 1 into this much, 1 into how much, 10 plus 4, 14 bytes are result. This is the way. It is set to null because the first data type is character set to null. Second is integer set to 0 because it is CLOK, clearing. Okay. So this is B1. Sorry, this is a node 10 bytes 4 bytes whose address is 6487576. Now B1 book ID is set to 113. What happens? See, in the same location it is pointing to a node. The first field is set to C plus plus book. This is a way to don't use equal for assigning the string, use strcpy. That is why string.h is used. Other field, book ID is set to 113. Yes. Next, I'll be printing it. Once you print it, you'll get the data in that 113 and C++ book. That is from B1. Now, I'll be using B1 to hold the address of B. I'll be using B1 which will hold the address of B. What happens now? B1 is a variable. B1 is a pointer variable. Address is 6487576. Just assume that this is a pointer variable. When I say pointer variable which holds the address, whose address? B's address. Where is our B? This is our B. This is our B, right? The address is stored here. 6487552. 6487552. Address of B is stored here. B1 is a pointer. B1 holds address of another node. This is a node. What is that type? It is the type. The type of this node is book. Type of this node is book. A pointer which holds an address. What is the length? What is the size of B1? Size of this address, which is a long. So 8 bytes. Size of a pointer is always 8 bytes. Size of a pointer is always 8 bytes because it holds the address. Now we'll see. Any guess? Address of B? Just see this address of B. Address of B. This is B. What is the address? 6487552. Next, what is address of B1? This is B1. This is B. B's address. This is B1 address. What is the address of B1? B1 is a pointer variable that requires a memory, whose address is 6487576. 6487576. Next, what is the content of B1? What is the content of B1? Content of B1 is 6487552. How to use it? B1. B1 content. B1 content. B1 content is 64875. That is B. Okay, in this way you can analyze it. When you're trying to print B1, you will get the new information, that is C book and 112, because you have pointed B1 to point B because of this line. B1, whatever the old data there now modified. B1 is now pointing to B. Okay. Now we'll see one example on union. A union unique ID is defined. The first field is character. Size is 20. Remember, maximum size till now it is 20. Integer 4 bytes. 4 and 20. Maximum is 20. Character pan 11. 11, 4, 20. Maximum is 20. Character other 13. 13, 11, 4, 20. The maximum is 20. So size of this union is 20 bytes. Remember that. Highest member with the highest size. The member mail ID which is having highest size, that is 20. Size of this union is 20 bytes. Got it? Unique ID, variable UID. Size of UID is 20. Type definition here is also used. Type def union unique ID unique ID. This is my alternate name. See, alternate name is used. Alternate name is used. This is a variable name. This is the alternate name for that union. Okay. Now I'll start assigning the value. UID dot phone number equal to 99009. Right now the active field is phone number. Right now the active field is phone number. Then you're changing the active field from phone number to mail ID. Mail ID is abcdfsimple.com. Active ID at this stage is in this union is abcdf at simple.com, that is mail id. Now again I'm overwriting that active field, only one field, that is pan. So later this will be a garbage value, this will be a garbage value. The value of this pan is ASDPO7712J. Now we'll see which is active field. What about the other one? Now, which is that active field? UID.pan. UID.pan. You will get ASDPO7712. 1172. Stay here. ASDPO7712. Actually, for phone number you stored 9909. But as it is a union which holds only one active member, others are garbage value. See, this is a garbage value. Even though we initialized here, no, it will be set to a garbage value. It is unrelated, nonsense information. So always union will save memory location. Whenever you have got only one such field is active, only one such member to be defined to be used, such case go for union. Okay. With this, I'll be wait. With this, I'll be ending my presentation. Thank you. Thank you for listening.